Okay, so I was talking about why have we started. The first thing I said is that this mission is close to my heart because the thing is that we have people who have less access to education, and they do not have proper guidance either. And the second thing is that I want to teach from a discovery point of view. I was explaining that point. So by discovery I mean that if you sort of face a problem and then you should feel it to solve it in that way, so you rediscover the solutions. If the solutions will be there, it is not that you have to reinvent the wheel still is there, but the understanding that you should have should be of a discoverer or should be of a person who has discovered it. That's the first thing I want you to take. Per se, I'm not here to teach you anything. Okay, I won't probably teach you the concepts, because that these concepts you'll get on the every book. I'll be successful if I can teach you how to think. That is my notion of learning. So if I can somehow inculcate the this thing into your head, that how to basically think about the world. Okay, there is a mechanism of thinking. There is a template of knowledge. So if you somehow got that template, and I'll be considering myself successful. You'll just not get the gold. You'll basically get a gold mine, keys to the gold mine. Okay, so my point will be to make you how to think. If I was successful in this, how to make you think. Okay, then if given in any problem or given in anything that you want to pursue, if you have this skill of thinking, that's what differentiates us probably from the animals, from the other animals. Okay, we are social animals, but what differentiates us is this thinking power. Okay, we have a sort of thinking, and that gets into us, and after that we can delve into different details of the things. Okay, the first thing is I'll love to teach from a discovery point of view, and you will feel that when we will start the lectures, I usually don't give the name to things. Okay, I'll first teach the things and then name them. Okay, we have also started a lecture series on functions and stuff. I probably, you can see that online also. The second point I wanted is this academy or the or wherever you are being taught right now. So most of the focus is on theoretic teaching. So they teach a lot of theory, which may be good from a research perspective or giving a broader perspective. But how I would like to teach is teach project oriented. So project oriented. So that's let's suppose we are handling some, even if we are handling total abstract mathematical things, we'll somehow connect it with the real world problems. Okay, and then we'll try to solve those problems. Okay? I believe in hands-on learning. Okay, so if you hear something and you will probably remember some things of it, but if you hear and see something, you will sort of memorize and remember more of that. So better thing is to experience it. Okay, so I believe in experiential learning. So when you are being experienced something, so that lasts longer. Okay, theory alone is sufficient in preparing individuals for real world challenges. Okay, so sometimes if you are, let's suppose, a pure researcher, you can just read about theory and you may not know how to implement these things, but it takes an effort from other people who understand theory, and they know the practical problems and how to sort of fill in these gaps of problems. So I want you guys, so whomever are the learners here, so I myself am a learner. I'm a lifelong learner though, so I'll teach from that perspective. We'll have real world problems, dissect them down, bring them into a mathematical framework and then computational framework, and try to solve them. Okay, and then as I said that this will be a possibility to, we'll try to, from whatever I have to share, so I'll try to give my best efforts. So I'll try to give my best efforts so that I'll make the education accessible. Okay, so these are some few points I wanted to talk about. So from this teaching the project oriented point, and we have our TAs, and we have a head TA here, and he'll be having some help. Depends on the size and the size of the classroom. Basically, if we have more people here, so we might need more TAs. So right now we have Sanmit here, so he will. So he's a physics major. He has a background in physics, computational physics rather. So I would like to request him to say a few words how he makes the assignment and stuff, so that you get some sort of clarity on what to expect in the assignments and stuff. Sanmit, are you there?
Yeah. Am I audible?
Yes, yes.
Okay. Assalamu alaikum, everyone. So, I am going to TA this whole course. I am going to make the assignments and also so I am going to expect in the assignments, and the assignments in this whole course there will be both theory and also computation. Also, like code writing will be there. So similarly, in the assignments we will have both the computation components. We will start off with theory, because otherwise, like, if you don't know the theory completely and a crystal clear point of view, then there is no point in mechanically coding it up. Because I mean, so if you do things mechanically, then probably AI will take over you, basically, because if you can't do it from in a genuine point of view, from a genuine perspective. So that's why, keeping that in mind, so the as Musavir sir said, the main point of this course is to induce critical thinking and thinking skills, because as we can see in this dynamic world, the skill sets you will need, it will be changing very often, very rapidly. So I think that it is not very valuable to valuable. It is not valuable about how much you have learned a particular concept, but it is more valuable that can you learn a concept, a new concept, in a very good way, in a very crystal clear way, in very quickly. So that is the main point of the course. So that's why we will completely start from the basics. We will start from the theory. So we will the mathematical backgrounds will be covered, and then we will build upon that, and then there will be the coding also. So that is the basic framework that we are going to have. And also, I would encourage everyone to be very consistent, and please respect the deadlines, because it is not only about the assignments, it's also about the mindset and the commitment that you express to this course. And it is for you, it is it is basically, it is directed to you. It is up to you that how much benefit you can reap out of this course. So it is completely upon your commitment to this course. So please be consistent in the deadlines, and the courses, the assignments will not be very hectic. They will be evenly spaced out, and everything will be taken care of. So please take care of that, and everything should be okay. And the outcomes are very nice. If you will also get the mathematical understanding of the basics, and you will also get the coding skills. And I will make sure that you go out of your comfort zone or the already established notions, so that you can get a flavor of what research is like, or what independent thinking of is like. So yeah, that is what all I wanted to say. Thank you for giving me this opportunity.
Thank you so much, Sanmit. Thank you so much. So I think we should get started. So please don't give me these boring looks. Please do speak and ask me questions, and make this session to be interactive so that I interact with you people. And it should be some sort of two-way communication. The whole point of having these classes live is that I want you guys to talk with me, so that you drive my thinking. So somehow, let's suppose if I start speaking about something, and if I if I ask, if I get no questions, so what will happen is there will be some monotonicity in my thinking. So I'll think in a direction, and I'll only talk about what comes up to my mind. But the best part is that if you somehow raise your hand, and if you have a silly doubt, I don't mind. Okay, you can just ask me any question that comes up to your mind, so that this is a two-way communication. This is somewhat different from whatever you watch on YouTube or something. I don't want you to just have your phone, put it there, and then just sleep. Okay, then that way you won't put much efforts there. So I want you to interrupt me anytime that you want, and ask me the questions and drive whole the class itself. And I want this to be a friendly environment, not just like a classroom where you can't. And you are basically anonymous to me. And if you ask any question, I won't bother. Is everybody with me? At least show some reactions.
Yes, Alhamdulillah.
Okay, great. So let me just get started about the things that we'll be teaching in the course. Okay, and so that you get a flavor what is coming after this. So let me just go to this page. I have prepared some PDF for you where I have just written some things. Okay, this is some sort of mind map. So we'll, as you all know, that somehow you might have received the message of mentioning what is this artificial intelligence. So most of you people are here because either you are a CS major or an AI major, or you are interested in artificial intelligence, and it is taking the world by a storm. Okay, so what basically is this artificial intelligence that we want to learn? And if you have seen recently ChatGPT and these deep fake things and many other things have been in the news for long now. Okay, and that's why most of the people are interested in this field. And now we are going to somewhat called as AGI, artificial general intelligence. We want to make AI agents so that they think like humans. Okay, this is a broad area. It's a philosophical question. It's a mix of philosophy, mix of mathematics, mix of computation, and stuff like that. Okay, and we'll start with this. So under this umbrella, it's a huge term. Okay, people were thinking of this AI. I think back since I think 1950s. The AI that we read today, even so that even backs to 1950. Even before that, there were some models, but serious thinking came into this. So when the Alan Turing came up with the paper, can machines think? Okay, so Alan Turing wanted to prove a point that if there are these nuts and bolts, and they wanted to think in some way. So that's what gave birth to this AI. And there have been many setbacks in AI also. So when the researchers overpromised things about AI, तो उनको ऐसा लगा कि everybody understands Hindi though. I just wanted to confirm it. Sometimes I may mix Hindi.
Yes, sir.
Nice. So I might mix Hindi in between. So if some of you does not understand Hindi, probably some people might be from South India. So please do tell me, so I can just keep it in English or the language that everybody speaks. So AI आया कहाँ से? The point is that we have an endeavor. Humans have this notion कि how do we think? They want to understand the things behind. It's not that we are animals कि हम लोग पैदा हुए उसके बाद हम लोग खाने की तरफ चल रहे हैं and then we want to find this habitat and food for us. Is there a question? I don't think so. So I was telling you the difference between humans and the animals. So that's a big difference between humans and animals. So when animals are born, they just care about the food and their shelter, and they have that. They are bewildered. If you see, let's suppose, a mouse coming out of the coming out of some hole or something, you will see that वो mouse क्या करता है? He looks here and there. Why does he do that? Okay, because he wants to be safe. उसका mouse का एक ही point है कि survival instinct. माउस डज नॉट वांट गेट किल्ड. ऐसा ना हो कि वहां बिल्ली है या कुछ है तो वो उसको खा जाए. तो ऐसे ही हम लोग इंसान वी आर वेरी डिफरेंट. सो वी थिंक अबाउट थिंग्स, वी ट्राई टू रीजन, वी ट्राई टू क्वेश्चन. Okay, that's why this sort of endeavor came in. Okay, I'm just keeping the science apart, I'm not delving more into philosophy. I'm saying where this artificial intelligence came. So this came as a curiosity. Can we make somehow machines learn? Is there a possible way that we can, whatever the things that humans are able to do? That's how we even define intelligence. Okay, so there are very different definitions of intelligence. It depends on what you consider intelligence. So but the basic intelligence that people consider is, let's suppose, if you add some things, if you subtract some things, और ऐसी calculations करना, या let's suppose writing some things, being in creative field like writing poetry or making songs or something like that. So people consider that an intelligence. So the big question was, can we somehow build some machines which will be as creative as humans, जो ऐसा हो कि जो humans की तरह सोचते हैं. So that was the endeavor people were at. Okay, then people made a lot of promises when they come up with these perceptrons, and that time some scientists came up with, I will talk about the history of when we'll come to deep learning, but when researchers promised the thing, and there are other people that again is that also. So one of the guys came and he showed that your perceptron cannot map the XOR function. So whole of this AI research, whatever the hype that was when it was in 1950s and 60s, so that went down. So एक winter आ गया AI में. So that's called as AI winter. So people stopped researching about these things, but some people still believed in that. And let me tell you one thing, and till now we do not know why this deep learning works so well. So there is no mathematical proof. People are trying to prove it mathematically, but these things work unreasonably well. Okay, and if you talk to people who are working in that field, they'll tell you that these things work, and sometimes we don't have mathematical proof. Why do they work? And before this, science used to be, there are two types of people. One are these theorists and one are experimentalists. Theorists are the people who build theory, and based on that theory, they'll build something, and they have a theoretical proof or theoretical guarantee this should happen. Okay, let's suppose talk about general relativity. So theory predicted something, and then we were in the endeavor of, okay, if theory predicted this thing, so what will happen in the practical? So let's suppose general relativity predicted that there should be the space, and let's suppose it also predicted quantum mechanics and things like that, and quantum mechanics predicted weird phenomenon. The mathematics of that predicted that, and then we were in the endeavor of finding the actual physical proof of that. But there are these experimentalists, so they will do experiment and they'll observe the phenomenon. Okay, so when they observe something, so they'll try to explain it. लेट्स सपोज तुम लोग कुछ एक्सपेरिमेंट करो. एक बच्चा जो होता है, ही इज मोर ऑफ एक्सपेरिमेंटलिस्ट. वो क्या करता है, ही विल डू सम एक्सपेरिमेंट एंड देन सी समथिंग हैपनिंग एंड देन ट्राई टू एक्सप्लेन व्हाई इज इट हैपनिंग. Okay, so everybody with me, I said that there are two types of people. The first thing is, I named them. I don't think I don't know whether you will get these names from the books or not, but I have a habit of doing this, inventing terms. So I said two types of people you will see. The first thing is experimentalists, and then there are theorists. So what theorists do is, they'll come up with a theory first. Okay, That's why this academia is so fond of this. They want to get these mathematical notions first. They want to get the mathematics right, and then after they will do something physical. Okay, and sometimes this tool is really powerful. So what happens is you'll predict something by using mathematics. Let's suppose quantum mechanics, it predicted weird phenomenon. It predicted something called as quantum entanglement, or it predicted something called as quantum tunneling, and relativity predicted something called as black holes, white holes, wormholes. So that all was predicted by the theory, by the mathematics. No experiment was done. Then we had the endeavor. We had that notion that we want to now actually see it in the physical world. Are there something called? Is there something called as a black hole? Is there something called as a wormhole? Or that's what theorists do. They'll do some theory and they'll come up something, and they want to see if theory is saying us something, does it exist physically? Then there are these experimentalists. So what are these experimentalists? So they'll perform an experiment and they'll observe the phenomenon. And once they observe that, so they'll try to explain it then, okay, by the knowledge they have. And sometimes they have to sort of break their boundaries of thinking also. So some phenomenon happens and they have to explain it. So current explanation, current mathematics or current knowledge cannot explain the thing. So that then what happens is you will somehow build new theory and try to explain this. So that's what the war was between. So when the deep learning and this AI and artificial intelligence, so there were people working on theory. So they were coming up with mathematical algorithms that this is how it should happen. Let's suppose this linear regression, logistic regression, support vector machines, and things like that. All of these are predicted by the theory. Okay, so we first did somehow invented them by using the theory, these different algorithms. But once the deep learning came, once this perceptrons came, these experimentalists came up. So they said, okay, let's mix and match these architectures somehow. Okay, we have a neuron, we'll put something here, something there, something, and they observed magical things. And initially, these people were taking a lead. So if you see historically, theorist people, they were taking a lead. Okay, they were having a theory behind that, and they're explaining the things. And slowly and slowly, experimentalist people, they start taking the lead. Even right now, ChatGPT is just an experiment. It's computing some function in a very high dimensional space, and you don't even know what it's doing. That's why it's very difficult to control them. You don't know what is it doing, and that's why I say they're working unreasonably well. You sometimes don't know where they're working even, but they are working somehow. Why? Because this is what experiments do. They'll perform some experiments, and they'll get a result, and they'll try to explain this. And right now we have really a lot of problems that comes in AI ethics and these things. Just want to give a context of like how the world works. So that's why AI comes in the picture, and we wanted to see, can we somehow make machines think? Can we somehow use the machines? Whatever we are good at, can we do that? Okay. Then you might have heard that Charles Babbage came up with an analytical engine, and they programmed it somehow. Okay, they made computation easy. Okay, that was the thing. So now I do not want to talk about the details of what AI basically is. We'll tackle that in a separate lecture. But I wanted to tell you what are we going to handle in this. हम लोग क्या पढ़ने जा रहे हैं? So AI, if you see, so the backing of the AI, how it comes, we'll go to the first branch of this. So that is the mathematical foundation. Okay. So whole of the AI, if you tell me, it is based on mathematics. Okay, there is this mathematical notion. So you must know about mathematics. Okay, so this is the foundation thing that you should have in order to understand the things. There are two types of again people. The thing is you can just import the things whatever has been done previously, but you won't understand a bit. Okay. But at least to get the notion, to get that intuition, how does these algorithms work underneath the hood? If you know a mathematics, your life will become way easier. Okay. And there are people who know a lot of mathematics than me. Sanmit probably will be more expert on different things of mathematics than me. But here we'll just touch some small things of mathematics. So again, this will be from a discovery point of view. I won't teach you mathematics, which you will feel that we have been taught in +1, +2, or maybe primary class or secondary classes. You should feel that you are discovering something. Okay, and you are trying to understand the world, and then you are trying to bring it to the mathematical world. Okay, the first topic that we'll be handling, which we have started with this batch even, that is functions and what are their properties, what functions basically are. Okay, this is what we'll do, and then we'll start to learn how to count things. This counting of things is really important. Okay, so there is a quote even, if you can measure something, you can control it. Okay, we'll learn this measurement. We'll learn how to measure things. We'll learn how to count things. So when you can count, you can somehow quantify things. When you can quantify, you have a lot of control over the things. Then after, I think somebody has a question. Yes.
Sorry to interrupt you. मैं क्या चाह रहा था कि अगर किसी को प्रॉब्लम नहीं है तो क्या हम ये हिंदी में सुन सकते हैं क्या? तो हमारे लिए समझने के लिए और भी इजी हो जाएगा.
We have a mix of people. I'll try to mix in. If I'm speaking fast, then please do tell me. I'll speak a bit slow.
ठीक है, नो प्रॉब्लम.
But most of the
अगर
people
सब
they are here.
कंफर्टेबल हैं तो
Yes,
अच्छा
yes.
अच्छा. अगर सारे लोग हिंदी में कंफर्टेबल हैं तो करेंगे, मैं तो नो इशू प्रॉब्लम.
I think more or less people won't be much comfortable in Hindi, and because the audience will be broader after this, so I would also love to keep this session in a mix so that everybody understands the things. So I hope that you can do
ठीक
this
है,
much. Huh?
थैंक यू.
Thank you so much for the
ओके
question.
ओके, थैंक यू.
So I was speaking about the mathematical foundation. So the first thing when you talk about AI, if you want to be a real good person in AI, you must know mathematical foundations. We'll start with what functions are. I don't want to delve directly into details, and we'll probably handle these things separately in separate sessions. Then I was talking about we'll do counting. We'll learn how to count things. So what's the rationale behind why should we count things? Why is it so necessary? So I was telling you that if you can measure a thing, you can control a thing, and you can do something about it. Okay, if you somehow measure a thing, you can quantify the things. That's why we'll learn to count many of the things. Then we'll come with the probability, and now you know that life is uncertain. There are a lot of uncertainties involved in life. बहुत सारी चीजें हैं जो हम लोग को नहीं पता होती क्या होगा, आज क्या होगा, we somehow don't know, and probably we might even plan कि ऐसा ऐसा होगा, but more or less कि हम लोग 90% times wrong होते. So in order to quantify that also, in order to quantify that uncertainty, we'll go with this probability theory. We'll learn to quantify these uncertainties, and then we'll cover the statistics. Again, this is again a science where we'll have data and we'll analyze a lot of data. So mostly if you sort of know the stats and probability, that's where these machine learning emerge from. As you know that machine learning or AI, it learns from the data. Okay, and the stats, it has really good concepts where you can somehow utilize these algorithms to sort of formalize them and use the computers to compute something. We'll seriously make it really easy. And then we'll go to this calculus and optimizations. Again, I hate to use these terms because I know that some people have associated bad memories with them. As in the +1, +2, they were so scared of this integration, differentiation. I don't want you guys to feel that because I want to introduce it again from the discovery point of view. You guys should be so comfortable with this so that if somebody tells you can easily formulate a problem in this calculus and differentiation integration, we'll get to know the gist of the calculus, and then we'll try to optimize. Okay, and most of the time in the world we try to optimize things. You have certain amount of money and you want to buy certain amount of thing and you try to optimize कि कैसे मैं इस money को utilize करूँ effective way में ताकि जो चीजें हैं वो maximize करूँ मैं benefit अपना. That's why even sometimes you try to minimize things, and we'll learn about optimizations. The heart of machine learning, I'll say, is called linear algebra. Okay, most of the notations we'll use in algebra and we'll use manipulations that comes from the algebra. So we'll also try to learn that. And then there's information theory also and graph theory we'll try to learn because they have some sort of connection with the artificial intelligence machine learning. I hope that this is the first foundation. Our course will not go that we'll only teach mathematics. So usually how I teach is that we'll have parallel tracks. So tracks will go like this. We'll be teaching mathematics, let's suppose in one session, and in the other session we'll be taking, let's suppose, some other thing. We'll be taking some ML algorithm. Okay, and then we'll be taking some other parallel track, something like that. Once I feel that you are comfortable with this mathematical thing and I can introduce a machine learning algorithm, I'll introduce that then and there. It won't be that you have to learn every concept in mathematics to go to machine learning. So we'll have a mixture of all of these. So probably 2-3 lectures we'll have, let's suppose, on functions. After that, I feel that you're pretty much comfortable in functions, we'll directly code something and we'll go to Python programming or something like that. Okay, so that's how the class will go on. So we'll be covering mathematics, machine learning, deep learning, everything that I'm speaking from I think from past 15 minutes. We'll be taking them parallel. It's not that we'll cover, there'll be a sequential order. So this order won't be sequential. It will be, we'll do something some parallelization. Okay, I hope this is clear to everybody. The second foundation, if you see, for the machine learning is this programming. You must know to program. I said you the problem was we have enough data now. हमारे पास 1950s में डेटा नहीं था, हमारे पास कंप्यूटेशनल पावर नहीं था. That's why these algorithms were not performing good. Why is ChatGPT performing good? Because it is trained on humongous information, exabytes probably. और जितने information पे ये train किया गया, if humans know this, probably they'll also speak something what ChatGPT speaks. There is a famous meme nowadays going on. So ChatGPT is asked, "Can you speak?" ChatGPT says, "Yes, I do speak, but I don't understand what I say." Because it all is a probabilistic model, and if given such a humongous amount of data, large corpus of data, and you are training it onto that, and these phenomena are the consequences of the training data. Okay, that's why now there is a whole hype between that, because now we have data and we have computation. हमारे पास बहुत सारा compute power भी अभी है, हमारे पास बहुत सारा data भी है. Now we can somehow harness that power. Now to harness that, you must know how to talk to a computer. अब तुम्हें पता होना चाहिए कि कंप्यूटर को यूटिलाइज कैसे किया जाए, how to somehow talk to that, because computers don't understand your language, they won't understand the direct language. You'll say something and they'll do it. Probably now ChatGPT does, but if you want to make a real progress, make a real something on the computer, you must know how to talk to a computer, how to talk to them, and for that you must know a programming language. Okay, so programming language in machine learning and AI. So we majorly use Python, or some people use R because it gives support to different libraries. So I want to per se again teach you programming. I won't teach you what Python is. I will again teach you what I call as art of programming. Okay, so I'll teach you art of programming. Because programming is a science also, it's more of an art also. The more you know it, the better you get at it. Okay, ये ऐसे है कि तुम लोग स्विमिंग कर रहे हो. What I can do is I can tell you the movement in swimming. मैं तुम्हें बोल सकता हूँ कि अपने हाथ ऐसे मारो, अपने पैर ऐसे मारो. जब तक तुम स्विमिंग पूल में जाओगे नहीं, पानी में जाओगे नहीं, and you don't move your hands and feet, you don't move your body in a certain way, you won't learn swimming. You may know a whole lot of theory till you don't get in the water and you do it yourself and you learn it for yourself. Till that you won't do it. Similar with the programming. So मैं तुम्हें बहुत सारी थियरी बता सकता हूँ. I can tell you this is how programming works, this is what the programming is, ये ऐसा होता है, while loops are there, there is something called as function, object oriented program, whatever there is. मैं बहुत कुछ बता सकता हूँ. But the point is, are you practicing it? If you are practicing it, then you will get better and you will sort of get this art. Okay, that's why I call it art of programming. So this is basically this is a science till an extent. I can teach you to a certain extent, but after that you must take it forward. You must learn how to talk to a computer in an efficient way, and for that we'll initially introduce what data structures are there in Python. Okay, what is the control flow, what are these functions, what is object oriented programming. Once you know how to talk to a computer, now you have to make sense of the data. अब तुम्हारे पास जो मशीन लर्निंग एल्गोरिथम्स है और जो तुम्हारे पास AI के एल्गोरिथम्स है, whatever you have, they basically are data hungry. उनको डेटा चाहिए and they learn the patterns from the data. Okay, for that first हम लोग क्या करेंगे, we'll try to visualize data. हम लोग अपने हिसाब से पहले डेटा का सेंस बनाना स्टार्ट करेंगे कि डेटा मुझसे क्या कह रहा है, what is it saying. Okay, everything tells you a story. So data will tell you some story. There will be some hidden pattern that you have to unveil. So that's why you'll also learn about data analysis and visualization. So in technical terms, sometimes it's called as EDA, exploratory data analysis. So you must explore data because there is a famous saying, garbage in, garbage out. If your model is being fed garbage, it will give output as garbage. So it is better like you clean the data. So you learn different processing techniques of data. You try to visualize data. You try to see what is the story the data is telling me. So after learning this Python, you will also know how to do the data analysis. Now again coming back, so you don't have to learn everything because now machines understand binary. Machines को क्या समझ आती है? They only know ones and zeros. Now you don't have to tell them okay ones and zeros and not even code in assembly and not even code in whole Python also. So there are brilliant people. So they have created Python libraries. Okay, so they have created this Python libraries. So what Python libraries are basically, this is optimized code. So which you will reuse a lot of times. Let's suppose you want to do something with numbers. So you'll use an library called as NumPy. Okay, you want to do something reading of the data and you want to manipulate data somehow, then you'll use pandas. Then there are libraries where we can visualize data, you can make graphs and things. You can use this matplotlib. So there are different algorithms which are implemented by really good brilliant scientists, and then we have a library called as scikit-learn in which we have these support vector machines and a lot of algorithms. I don't want to take the names, but what these are basically, you don't have to reinvent the wheel. You don't have to use code everything from scratch, but I would love you to code from scratch. But more or less, you will have to learn how to use these libraries also, how to use the code that is written by somebody else. Most of the work that I do, so it is related to writing these libraries. Okay, we write these libraries so that the people who will be coming into AIML, who will be coming into this, they use the library directly. Okay, and after that we'll be learning this TensorFlow, Keras, OpenCV, NLTK for natural language processing, this PyTorch for deep learning. Then we have the SciPy scientific computation for the time series, and then we have again NLP modules, and we have a lot of libraries like this. I've just named a few of them. Probably we won't be going through all the things. Again, coming back to my point, I won't teach you all the libraries, but I'll teach you how to think basically. Okay, somebody is putting the links, you can also check that out. So these are the libraries probably we'll be touching. We'll touch NumPy, Pandas, Matplotlib, or PyTorch, maybe few of them. And then once you know how to utilize them, how to read documentation and how to go on these pages and how to utilize everything that is there for a library to offer, then we'll be done with this. We'll be done with the Python. Now you have two skills. Once you know this, once you know mathematical foundation, अब तुम्हारे पास mathematical foundation आ रहा है, and then you know how to talk to a computer. तुम्हें अब ये भी आ रहा है कि कैसे बात करना है एक computer से, how to talk to it. So now the main important thing comes in. Okay, how to merge these tools and come up with the machine learning. This is the third part, which I have branched it here. Okay, so once you know how to program, once you know how to talk to a machine, and you know the mathematical foundations, you are not being experimental, you are being theorist first. Okay, knowing something and then conveying it to a computer so that it understands the things. तो वो चीजें जब तुम्हारे पास आ गई, then you combine these things to come up with this machine learning. Okay. So AI, machine learning, they are just we'll have a separate lecture discussing about what the difference, what AI is, what machine learning is, what deep learning is. Here, do not even be concerned about the thing. Why haven't we put this deep learning in the category of this under AI or something like that? I've just made the things that we are going to cover. So if you see this machine learning, we'll have a detailed discussion on what learning means. So what is even meant by the learning? So even if I speak at the broad level, so there are different types of machine learning. The first type is that the thing that is common in machine learning is that it learns from data. You are learning something from data. You are trying to find hidden pattern. हमारा पॉइंट ये है कि हम लोग पैटर्न को ढूंढ लेते हैं. We try to somehow come up with the patterns. एक डेटा हमने देखा, इसमें क्या पैटर्न है. That is what we try to unveil. There is one thing called as supervised learning. Supervised learning में क्या होता है? You have the data and you have corresponding labels to the data also. Putting it simply, let's suppose you want to do image classification. अब हमारे पास क्या, हमें image classification करनी है. Okay, then here I have opportunity to also clear up what machine learning basically is. I'll just zoom it a bit. So if you see what this machine learning is, okay, तो हमारे पास पहले क्या हुआ? The thing was we used to code everything. So let's suppose you have to make a computer to let's suppose fly a drone. So हम लोग क्या करेंगे? We'll write a set of rules or set of lines which will describe what's called an algorithm. We'll write an algorithm. So what will that tell is, it will go line by line, it has a flow control and everything is there, and basically it's a set of rules. If this happened, this should happen, else this should happen, for or something, iterate these many times. So they are just bunch of rules. This algorithm is bunch of statements and things like that. What will happen there is, so you are predefined, explicitly programming a thing. Okay, so then you are achieving your task. That's what classical programming does. This is classical programming. Okay. So we have an algorithm. Algorithm is nothing but a bunch of statements that you execute in order, and there is a flow control, there is some iteration also. Okay, and that's what you do. But in machine learning, what you try to do is, now if you have to identify, let's suppose this is the image of a cat. हमारे पास cat है और हमारे पास image of dogs है. अब कितने rules लिखेंगे हम लोग? If we'll say that this image is made of pixels, ये image भी हमारे पास pixels से बनाई गई है. So we have these pixels. We'll have to write huge number of rules, and even then it will fail. Somehow, if you see this 8 and if you see this 8, both of them are written differently, and in order to write a program for that, to tell computer this is 8 and this is also 8, you have to come up with some rules. So now this becomes a daunting task. It's very difficult to come up with the rules कि कौन-कौन से rules मैं लेके आऊँ कि हर एक pixel को बताऊँ, if this pixel has this, if this has pattern this, and you have to write rules, you have to explicitly tell this, and most of the times it fails. So what we try is, we try to feed the algorithm a lot of data. हम लोग बहुत सारा डेटा देते हैं एल्गोरिथम को, and somehow algorithm learn the pattern itself, and now algorithm will be able to call this is 8, this is also an 8. Similarly, if you feed an algorithm the image of cats and dogs and tell it, give a function to that, tell it to optimize this, these are the image of cats, these are the image of dogs. Now there are two scenarios which you can do. The first scenario is that you can give this data and you can give the corresponding labels also. By labels I mean you give an image और corresponds पे ये भी लिखा है कि is the cat or a dog. Okay, that's what I call a label. And this image I call a data point, or data भी दोगे और corresponding label भी दोगे. If we learn in this way, we give a label also and we give data also. If we give label plus data, data means an image and label means corresponding name of the image. Okay, that is called a supervised learning. There is something supervising it. कोई तो supervise कर रहा है इस चीज को. कौन चीज supervise कर? That is label. We have these labels also. So in that we learn about a lot of algorithms. We learn about linear regression, logistic regression, support vector machine, decision trees, random forest, naive Bayes, k-nearest neighbor algorithms, and probably a lot more. We won't restrict on this. I just wanted to show you that there are algorithms that fit into that realm of this supervised learning. Okay, and these algorithms, most of these are backed with theory. They have a strong theory, and most of these algorithms were discovered before 1980s. ये सारे जो algorithm थे ना, ये सब के सब discover हुए थे, but now we have data to learn from them. Okay, and we'll learn the theory around them first, and then we'll try to code it. And as I said, that we'll have this parallelization. We'll parallelly learn about all of the things. Okay, now we are in the realm of what this machine learning is. So we'll learn what's called as supervised machine learning, where we have the data and we have the labels also. But sometimes we only have data. हमारे पास label नहीं होते. Let's suppose you have a bunch of documents and you don't know what this document is about. Some documents can be of finance, some documents can be of healthcare, and some documents can be of some other type. So you don't know what these documents are all about, but you have a bunch of data. Okay, so then we come up with this what's called as unsupervised learning. So what is unsupervised learning? This unsupervised learning is basically when you have only data, you don't provide labels, there is nobody to supervise. अब हमारे पास label नहीं है corresponding, हमारे पास सिर्फ data है, and now we want to make sense out the data. हमारे पास कुछ data पड़ा है, and you have no label, and you have no sort of clue कि ये data क्या represent कर रहा है. And then what we do is you just have a goal. You have a goal in the head. Somehow I want to classify the data, or I want to do something with the data. So for that, we are doing what's called as unsupervised learning. Data and no labels basically. For that, we'll learn what is called as clustering. Okay, we'll learn and clustering algorithm, and there are a lot of clustering, k-means clustering, hierarchical clustering, TB scan, mean shift, and a lot of these. Okay, we'll try to cover all of these algorithms probably. So clustering में हम लोग बहुत सारी चीजें पढ़ेंगे. How to cluster the things. If you have data and it has no labels, you have to cluster the things. Okay, I'm not explaining the things because I don't want to bore you with the details, but I'm just showing you that we are doing this macro study. Okay, by macro study I mean that I'm just showing you the zoom out lens. I'm just zooming out. Let's suppose you came into a garden और उस garden में बहुत सारे पेड़ लगे. I'm not taking you to each of these plants, each the tree, and showing, oh, this is an apple tree, this is a mango tree. What I'm doing is I'm just showing you a macro view. I'm showing you that let's zoom it out, and there are these trees only. I won't get you to all the trees all together. I'll just show you a macro view of that. That's what unsupervised learning is. Then there is dimensional reduction also. Sometimes your data is high dimensional, and maybe some terms might not make sense to you. It's all right. If they don't make sense to you, please bear with me. Okay, I just want you to sort of get the hang of these things. It's all right if you don't understand the things. It's all right. Because this is just just showing you if you don't understand the terminology, if you don't understand my terms, it's all right. Okay, and even sometimes if I speak faster, maybe after 2-3 lectures you'll sort of get accustomed of hearing me, and then you'll probably be able to understand whatever I speak. Okay, so this is another algorithm. So these are algorithms where what happens basically is you have data which is of high dimension. हमारे पास बहुत dimension में data lie करता है, and now I don't expect that you know what dimension is basically, because that is a mathematical term. Okay, in that we'll again learn about principal component analysis. We'll learn about LDA, linear discriminant analysis, and you'll see what is called as TSNE. Okay, there are these algorithms which by the help of which you can reduce the dimensions. Okay, these are called, you might have heard about compression also. हाँ, तुम्हारे पास एक फाइल है, let's suppose, अब उस फाइल को हमें compress करना है. Okay, and there is something called as lossy compression and lossless compression. Similarly, dimension reduction is that technique. So where what you do is, so you have a high dimensional data, so but basically you want to reduce the dimension. So what's the advantage? बहुत सारे advantages है, जैसे computational complexity में बहुत फर्क पड़ता है. So if you have lower dimensional data, your algorithm is faster. You want to do that. Again, I don't expect you to understand everything. It's all right if you do not understand everything. It's all right. But bear with me. Just know that these are things that we are going to learn. Then there is what is called as reinforcement learning. Okay. Probably we won't touch this much, but I just wanted to show you that there are these three learning realms. So machine learning has supervised learning, it has unsupervised learning, and the reinforcement learning. So in the reinforcement learning, what we have is we have an agent, and then we have an environment. Agent interacts with the environment. Okay, and environment, it gets a feedback. That's usually how humans also learn. So we interact with the environment. हम लोग अपने environment से interact करते हैं. What happens is उसके बाद हमें कुछ feedback मिलता है वहाँ से. Let's suppose we got a positive feedback. Let's suppose you speak a certain thing और तुम्हें बहुत claps मिली उस पे, and you got appreciated for that. You will try to do it again and again. Okay, that's called as exploitation. You have some states, and this is again a huge subject in itself, and we probably won't be touching it much. Okay, this is again a huge subject, reinforcement. But if you somehow understood the supervised, understood the unsupervised learning, somehow you have understood a part of what is called as classical machine learning. So that was discovered before 1980s. Most of it was discovered before that. Okay, and now deep learning is basically not one type of how we learn. It is separate subject, but I have just kept it under machine learning. Okay, deep learning is where we'll try to get an inspiration from how a human brain works. Okay, जैसे हम लोगों का brain कैसे work करता है. It works because in our brain we have neurons. We'll get an inspiration from that, and scientists tried to take an inspiration and tried to somehow replicate that systems. जैसे हमारा neuron work करता है, and it has a huge history in itself. वो ये न्यूरॉन्स को इंटरकनेक्ट करते हैं, एंड देन हाउ डू दे process the information. Okay, this was studied and taking that inspiration, and then we wanted to replicate somehow that into deep learning, and we'll start with what's called as feed forward neural network, or called as multi-layer perceptrons. Okay, we'll start with this feed forward neural network or multi-layer perceptrons. Then once we go to them, now we want to identify image. As I said that to write the rules explicitly is a daunting task, and then identify. Then people came up with this CNN architecture. They are called convolutional neural networks. Again, they are somehow mathematically backed. Okay, and then we have these recurrent neural networks. Okay, then we have these LSTMs. I do not want you to get scared of the terms. Probably some of you might know the terms, some of you might not know the term, but it's all right. Okay, I'll make sure that by the end of this course, you guys know all of these terms. And then we have something called as GRUs, gated recurrent neural networks. And then we have deep leaf networks, then encoders, then variational autoencoders, then generative adversarial networks. Okay, then we have what's called as transformers. This is the thing that is behind ChatGPT. Okay, we'll learn this architecture also. There is something called attention is all that you need. The paper attention is all that you need. Okay, now again zooming out. So what did I say? The artificial intelligence lies on two main things. The first thing is mathematics. So you must know what is the mathematics, what does the mathematics offer, what has mathematics to offer. And the second thing is that you must now know how to talk to a computer, how to talk to a machine. There you must know a programming language. And once you have these two sort of skills, you have mathematical foundation and you have this programming also. Now you can develop into the machine learning. Once you knew the machine learning, you basically are taking this mathematical foundations, and you are now taking your programming skills and you are making them together and coming up with these algorithms. The most important thing that there is called as domain expertise, because now you are solving a problem. Think, you are being a machine learning scientist, whatever it is, you are being a data scientist, data analyst, or you are writing an algorithm, you are using machines do something. But वो चीज करनी है ना किसी domain में, we have to have, this is just a tool and you have to do something there. So that is where this domain expertise come in, क्योंकि हम किसी domain की problem solve करेंगे. Let's suppose Sanmit is from physics, so he's using machine learning or the tools of mathematics, tools of computers to solve physics, to solve physical problems. So he's having a problem, he had to formulate in mathematical terms and then write a program to compute the thing. So basically he's using it as a tool. Similarly, we'll be doing the same thing. Once we know these tools, so we are just learning tools as of now. So you have the tools now, so you'll have to use it somewhere. So that is where this becomes important. This domain expertise become important. Domain expertise क्या होता है कि let's suppose you are solving a problem in healthcare. This problem is again dear to my heart. So I am closely working on this. अगर तुम्हारे पास एक patient data है, now you know that these doctors are inaccurate. So I'll just, no hate towards doctors though, but doctors are at number 3 in accidental deaths. At number 3. What do I mean by accidental deaths? So let's suppose किसी को God forbid car ने hit किया and he died, or somebody fell from a building. All of these are considered accidental deaths. अब ये डॉक्टर्स जो है ना, इनको कुछ दवाई देनी पड़ती है और इनको कुछ ऑपरेशन करना, but they did some mistake and the death was accidental and they are at number 3. That is by human error, because humans can't be precise and accurate because of their emotions and a lot of things happen. Maybe a doctor is not in a good mood, or doctor is somehow disturbed and he did something and it costed somebody a life. So for this healthcare, what we can do is, if we have data about patients, अगर हमारे पास बहुत सारा data है patients का, and now if we are able to somehow use machines to predict some things, कि ये जो patient हमारे पास है, what is the probability or how likely is it that he'll get some fatal disease in coming years or something like that. It'll be really empowering for the healthcare sector, and being from countries where our economy is struggling, so this will be a great tool. Okay, it can, so you can on just mobile phone. I think this will be a reality after 5 to not even less than 5 years. You'll just have your mobile phones and you'll just scan your test, and your there we have an AI algorithm there. It'll just tell you, okay, you have this deficiency in the blood, you should take this and you should take these precautions. Okay, and then finance. Everybody loves finance. Most of the people whom I am working with, they love finance. Okay, so what is the finance? Let's suppose you are working in a banking sector and they want to see if there are some people who are committing fraud. Okay, एक ट्रांजेक्शन कर रहा है कोई बंदा, एंड यू वांट टू प्रेडिक्ट क्या फ्रॉड तो नहीं हो रहा ट्रांजेक्शन के साथ. इफ यू हैव एल्गोरिथम्स एट प्लेस जहाँ पे किसी ने सपोज डेबिट कार्ड या क्रेडिट कार्ड स्वाइप किया एंड ही वांट्स टू मेक अ ट्रांजेक्शन, ही आर शी वांट्स टू मेक अ ट्रांजेक्शन, हम ये बता पाए इफ इट्स अ फ्रॉड और समथिंग. एंड इवन इन फाइनेंस यू कैन हैव स्टॉक मार्केट्स. इफ समबडी ऑफ यू आर इन्वेस्टिंग इन स्टॉक मार्केट, तो वहाँ पे तुम पहले ही प्रेडिक्ट कर पाओ. ओके, कि कल स्टॉक ऊपर जाना है, कल स्टॉक नीचे जाना है. इफ यू हैव सम टूल्स लाइक दैट. ओके, एंड इवन इफ यू नो देयर वाज अ गाय नेम्ड एज Simmons. Okay, people may pronounce it as Simon. So he was the guy. He used these mathematical tools to model the stock market. I think he earned somewhat around, I don't exactly know the figure. I think around 10 plus billion dollars. Okay, that's just by using the mathematical modeling and this machine learning. So this is for the people who are interested in finance. Then you can have automotive sector, and you can have retail, manufacturing, agriculture, education, and again this topic is again close to my heart. How to sort of use this AI into education. Okay, we are working on some LLM based education platform also, so you'll get to know all of these things. So that's why I'm saying this. You must have domain expertise. Let's suppose right now in my work we are working on something called a custom LLMs for construction. For that, I had no clue about what civil engineering is and how do these structures are made. But I have to learn that because I want to now use LLMs or use these generative models to sort of make these buildings. For that, I must know what is the building, how it is made. I must have the domain expertise. Most of the people don't focus on this, but this is a very important focus area. कि अगर तुम्हारे पास अब सारे के सारे टूल्स भी है बट यू डोंट हैव डोमेन एक्सपर्टीज, अगर डोमेन एक्सपर्टीज नहीं है तो प्रॉब्ली यू विल बी गुड बट यू विल हैव टू लर्न डोमेन. अब तुम्हें डोमेन पढ़ना पड़ेगा सो एज टू यूज दीज टूल्स. How many of you understood this sort of, I'll say a roadmap or a guide, how we are tackling the problem? या लोग सो गए, मुझे नहीं पता कि लोग सो गए. I might be what's called spreading that sleeping gas or something.
नहीं यार कोई नहीं सो गया.
Who else is still here? Can you just show a raise of hands? Are you enjoying the session? Okay. So this is the broader roadmap. This is the broader roadmap that we'll be covering. Okay. And probably in the next session, we'll be again taking the functions. And before that, we have covered a lecture. Probably you'll get a link to that lecture also. Okay. So this is the broad roadmap that we'll be following. And this is tentative. We may bring some change depending on like what is suitable for you people. And I consider that most of you people, I am teaching undergrad people. Okay. Many people get pissed off, but it's all right. I teach to the lower 20% of the people. I don't teach to the people who know most of the stuff. I teach the people who only have the background of +1 or +2. So I'll just consider that you have background. You have even background 10th background. You don't have more background than that. You have this 10th level background.